Guys, welcome to lesson 6, the second last lesson of the nuclear physics topic. And today we will be going over fission, nuclear fission and fusion. Nuclear fission and fusion. What the hell is this? Dylan, you speak so bloody fast. You speak so fast. Okay, Dylan, what the hell is this? You speak fast. Yeah, you get it. I speak fast. Alright? Fuck off, I don't care. I'm the teacher. I got all the work. Here I need to teach first. So shut up. Now we're gonna do this. So basically, here's the thing. Energy, we all know, is released from nuclear reactions, right? You should know that if you watch beta and all that. Our gamma decay videos. So fission releases a lot less energy than fusion. Fusion releases a lot more energy than fission. Fission's energy that gets released is a lot less than fusion's. So this is basically a less than symbol here. So fission's energy is less than fusion's. Fusion's energy, since it's the other way around, is greater than fusion's. I'm guessing you guys should all know what less than and greater are. Use the crocodile method, whatever way works for you. Crocodile method. The mouth always faces the bigger one. I think you get the bloody point. Anyway, sorry if I'm in a grumpy mood. I'm just really frustrated because I just spent 16 minutes doing a video on Half-Life. It should have really only been 10 minutes. Okay. What is a fission? Let's start with fission. Nuclear fission. I need to get this done soon. Next 4 or 5 minutes. 4 or 5 minutes. Okay, so fission. Fission is what this is. Fission is splitting a large nucleus, usually by adding a neutron to the mix. Nuclear fission, splitting a large nucleus by adding a neutron. Hopefully you guys will write that down. Pause if you need to write or do the questions later on. Anything you need to do, just please pause. So we have, this is an example of a fission equation. So yet again, numbers top and bottom balance. You should all know that by now. We've got uranium-235, and if we add 1 neutron to it, this is actually the first question. No, I'm going to go through the first question. I'm just not even going to bother with questions. What I'm going to do is I'm actually just going to show you the questions early. You guys can attempt them early, and then I'll go through them. Okay, so you guys can attempt the questions early. Basically, what this is going to make is blank. It usually also releases some neutrons. So I'm going to put an X there. You guys have to work out how many neutrons on your own. Also gives us whatever this element is, 148 La. And we also get one more. We get bromine 85. So what we're done here is we're taking the uranium-235, added a neutron, that's split it into some neutrons and other 2 daughter nuclei that are absolutely massive. It only works usually with bigger nuclei, so like uranium-235, plutonium-239 works, that sort of stuff. So basically, if you did all the calculations here, so you know, for starters, 235 plus 1 has to equal X amount of neutrons, right? Plus 148 plus 57 plus 35. So let's, for starters, let's work out all the rest of the numbers. So we all know this one's going to be 236. So I should just write it. Oh, this is so bloody small, this whiteboard. I should probably read it all this. 235, 92. So you already know 230. This one has got to equal X plus 148. So X is the number of neutrons that gets released. So neutrons have no atomic mass, they've got no protons, just a neutron, so just 1, 0. So remember this, neutron. What was that? That's a neutron. You guys also want to know what other ones are. A proton, we discovered what electrons are, just beta minus particles. Protons is just a hydrogen. That's what you usually write. You can also write them as 1,1p, but I usually write them as 1,1h. That's just a hydrogen, that's really all it is. So this is our equation. So 148 plus 85. 233. X. So X is our number. X is how many neutrons. That's essentially what we're trying to solve. 236. So we already tell if we minus 233 from 236, we're going to get 3. That equals 3, right? So we've got 3 neutrons. So the way we'd write this now, I hope you guys attempted this, by the way. So neutron fizzled together with uranium-235 will produce bromine-85, 147, 57 La, and 3 neutrons. Now, I really need to go into my chemistry class because I am still a student. So, what I'm going to teach you guys now is the next question real quick. I'm going to go through it real quick. The next one is a fusion reaction. Fusion, as discussed earlier, produces a lot more energy. So, essentially, all we're doing in a fusion reaction is we're putting 2 smaller, remember around the fizzle we got split a big nuclei, we're fusing 2 smaller nuclei, this time not bigger, together instead of splitting them. So, look at this. Fusion, smaller together, smaller and together. That's a fusion reaction. Fission is bigger and splitting. So write that down, if that makes sense. Fusion, we're splitting smaller isotopes and putting them together. Fission, we're usually bigger and splitting them. And both of them, there's neutrons involved with both. So yeah. This is a fusion equation. I'm going to put an X here and see if you guys can work out what the bigger nucleus is. So we've got a neutron. What do you guys reckon is? Take a pause and work it out. Okay, it's pretty simple. So 3 plus 2 on the top is going to equal X plus 1 minus 1. That's 5 minus 1. So it's obviously it's going to be 4. It's going to be 4. Alright. Next step. All we need to do is calculate the next one. So what's 1 plus 1? Does that equal 0? No, it's 2 minus 0. 2. What's that? Helium. That's all it is. Just balancing. It's a different way of doing it. No decay occurs. You're just fusing something, splitting it, or fusing 2 together. That's all it is. Seriously, that is absolutely it. Thank you for watching, guys. I hope you enjoyed.